All right, today we're going to talk about polar coordinates. I said last week, or earlier in the week, that I put on polar graph paper for us to print out. Hopefully you were able to do that. If you did not, you need to let me know so I can maybe put some graph paper at the front desk at school so you can come by and get it. You will need this graph paper to do your quizzes or tests or whatever we have. So if you can't print it out, you can't make it work one way or another, which is fine, you need to let me know. For today, you may need to draw the best you can a circular graph and do what we're doing. All right, so before this unit, we graphed rectangular equations. Rectangular equations have x and y's in them, and only x and y's. Last class was our parametric. Parametric was x, y, and t. X, y, and t was parametric. And today, we are going to do polar, which is going to be r's and thetas. All right, so xy is rectangular, xyt is parametric, which we just did. Today is going to be r's and thetas, are going to be our ordered pairs. So our polar coordinate system from a fixed point O, our origin or a pole, which is our vertex. We're going to construct an initial ray, which is our polar axis. That's our initial side of our angle. Okay. Our polar axis is going to be the positive x-axis, which is going to be the initial side of our angle. Our ordered pair, r comma theta. We're going to get an ordered pair, r comma theta, where r is the directed distance from O to P, from my vertex to my point. It's a directed distance, and theta is my directed angle. R is my directed distance. Theta is going to be my directed angle. Science is Thursday for someone who asked. Science is Thursday. Math is Wednesday. History is Tuesday. English is Monday. All right, so our ordered pair, r theta, we're going to have an angle. We're going to rotate our angle theta, and then we're going to go our distance in a certain direction to our point P, r comma theta. What we're going to end up doing today is we're going to graph points. We're going to find other ways to write the same points, and then we're going to convert from polar to rectangular, from r's and thetas to x's and y's, and then we're going to convert from x's and y's into r's and thetas. We're going to do conversions of points, and we're going to do conversions of equations. So we're going to plot, we're going to write some more representations of the same point, and we're going to do a bunch of conversions. Next class is I'm going to give you equations, and we're going to draw cool looking, neat, nerdy little math graphs. I think they're fun. They're cool to get out and see how they work. We're not going to do a lot of the math. We're just going to have to do the setup of the math. All right, so we're going to have an angle. Our polar axis is our initial side. Our pole is our origin. That's the vertex. The r distance tells us how to get to our point, how far we're going to go to get to our point. All right, today in class, we're going to graph 2 points to start. We're going to use the same polar grid. We're going to use one circle, And we're going to plot both points on that and just label them as number 1 and number 2. There's no reason to put a 1 point on one graph and then put another point on another. So we're going to conserve graphs. Tonight, how many points do you have to do? Well, it's all on WebAssign, so it's not as big a deal. But if you do it on your paper, plot them all in the same, just to save a little bit. So again, rectangular is x's and y's. Parametric is x, y, and t, or theta. And polar is going to be r's and thetas. All right, so we're going to rotate an angle and go a distance r in the correct direction. All right, so we're going to plot the point. 2 comma pi over 6. We're going to plot the point 2 comma pi over 6 on our polar grid. All right, the ordered pair 2 comma pi over 6, 2 comma pi over 6, my r comma theta, is going to be the point at the intersection of a circle with a radius of 2 and a terminal angle of theta equals pi over 6. So I'm going to go to my angle pi over 6, and then I'm going to go out 2 circles. All right, my graph paper does not look like yours at home. If you printed your own at home, it does not look like this. Your graph paper at home does not have these lines. Okay? So if you're at home, I'll just kind of mark out some of them a little bit, does not have these. We are going to use these later. We'll just get rid of them for now. All right, so this is what we have. All right, so what we're going to do is we're going to find the angle pi over 6, and then we're going to go out to the second circle. All right. When you do these, have your tests on a quiz where you have to turn the work into me. I need to know which way to hold your graph paper. Okay? The graph papers you have aren't labeled, so what we're going to do to start is we're going to label 0, pi over 2, and pi. So then when I pick up your graph paper, I know what direction to hold it in. When you staple it to your paper, if you don't label it, you may staple it upside down, and I'm going to grade it as if it's upside down. So make sure you do a little bit of labeling just so I know which direction to look at it. All right, the next part of this that we need to recognize is this is almost just like our unit circle, where these angles here, or these lines, let's do it that way, are my pi over 6s. The one in the middle, these, are going to be our pi over 4s, and the last ones are our pi over 3s. Okay, it's the same angles as my unit circle. Pi over 6 are the ones next to the x-axis, pi over 4s are the middles, pi over 3s are the ones next to my y-axis. All right, so that's our setup when we do it. So what we're going to do is I'm going to find my angle pi over 6. So I'm going to realize that this angle here is my pi over 6 for this ordered pair that we're doing. So I'm going to find my angle pi over 6, and then on that angle pi over 6, I'm going to count out 1, 2 circles and put my point. That's my ordered pair. This is the ordered pair, 2 comma pi over 6. So I'm going to rotate to the angle pi over 6 and realize where that is. And then because my distance is positive 2, I'm going to walk out on that angle 2 circles and put my point. That's 2 comma pi over 6. So find the angle and go that distance. Count that circle. All right, let's do this one. Negative 4 comma 2 pi over 3. Negative 4 comma 2 pi over 3. So on that same grid, again, mine has more lines than yours, which isn't a big deal. Negative 4 comma 2 pi over 3. I'm going to find my angle, 2 pi over 3, which is going to be this angle. 2 pi over 3 goes 1 pi over 3, 2 pi over 3 in a second. And that's just knowing our unit circle. All right, but now, on that angle, I want to go the distance negative 4. So when I went a positive 2 in the last problem, I counted out 1 circle and 2 circles. If I want to go negative 4, what I'm going to do is I'm going to extend this graph, this line, into the 4th quadrant also. I'm just going to extend it a little bit, realizing I'm on that line. And now, to go the distance negative 4, I'm not going to count out going into the 2nd quadrant. I'm going to count backwards, 1, 2, 3, and 4. So if your distance is negative, do not walk out onto the angle that you want. Walk backwards away from it. So instead of going on 2 pi over 3, I'm going to walk backwards 4 circles and put my point. And that's my ordered pair, negative 4 comma 2 pi over 3. A positive distance, you're going to go out onto that angle that you rotated to. A negative distance, you're going to go backwards away from that angle. So if the angle we want is in the 2nd quadrant, I'm going to walk backwards into the 4th. If the angle I want is in the 3rd quadrant, I'm going to walk backwards into the 1st. Negative distance, walk backwards on that line. A positive distance, walk forward onto that angle. And that is how we graph polar points, polar coordinates. Next class, we're going to find a whole bunch of them that are going to give us a cool looking graph to draw. Anybody have any issues? Something that doesn't look right? Something you don't understand? So rotate to the angle. If it's positive, go onto the angle. If it's negative, go away from the angle. All right, the next thing we're going to do is we're going to find, I'm going to say 4 more polar representations. We're going to find 4 additional polar representations of the points that we have. And I'm going to go back and look at the graph so we can see it a little bit better. So we're going to find 4 additional polar representations. I'm going to find 4 other ordered pairs that'll put me in exactly the same spot as 2 comma pi over 6. We're going to find 4 more ordered pairs that put me in exactly the same spot as 2 comma pi over 6. So I'm going to go back to here just so we can look at it better. All right, so what I want to do, I want to find an angle and a distance that'll put me at the exact same place as this red dot. So the first time we did it, we rotated pi over 6 and went out 2 units. Can somebody give me another angle and another distance that'll put me in exactly the same place? A different rotation, maybe a different distance. How can I get to that same exact place? Or tell me how to do it. Maybe you don't know an angle, tell me how I can do it.
You could make that a negative
Okay, so if I make my distance -2, where do I want to be? In what quadrant do I want to be? If my distance is -2, I want to be in the third quadrant, right? Okay, so I want to be here. This is the angle I want to be at. So I want to rotate to here. And then go backwards. And I'll give you that. Someone said 7 pi over 6. So if I rotate to 7 pi over 6, which puts me into that third quadrant, then rotate and then step back 2 units, I get to the same place. So I'm good with that. So -2 comma 7 pi over 6 will put me in exactly the same place. I'm going to rotate to the third quadrant and walk backwards. All right, give me another one. And I'm going to ask for 3 more. Anybody else got one that'll get me there? All right, someone said 2 comma 13 pi over 6. I'm good with that. So if I rotate all the way around and stop at that same place, which is 13 pi over 6, I'm going to go out the distance 2. So I added a complete circle and got back to where I started and went that distance. I'm fine with that. Okay, but we're going to find 2 more. I want another one that has a distance of 2 and another one that has a distance of -2. So what is another angle that's going to tell me to walk out the distance 2 to get to that same point? How else can I go out the distance 2 and get to that same place? Thinking too hard. How else can I go out a distance of 2? How else can I get to that same angle and go backwards? Yeah, we could go 25 pi over 6 by adding another full rotation. Let's do it differently. Can I do this and rotate down? Okay, if I rotate down and stop at pi over 6, that angle is going to be negative what? I stopped 1 pi over 6 short of going all the way around. All the way around is 2 pi. So if I stop 1 short, it's -11 pi over 6. So if I rotate down all the way to get me to that same angle that I started at and go out a distance of 2, I'm at the same place. Now, using that idea, what's that last ordered pair? -2 comma what? How else can I do the same idea but go backwards and end up there? Can I rotate down to here? And then go backwards, that blue one, which will be -5 pi over 6. And those are 4 additional polar representations of the same point. All right. So now, if I ended up on the same angle, I did the same distance. If I ended up on the opposite angle, I did the opposite distance. All right. So, when I want the same R, what did I do to my angle if I want to keep the R the same? What did I do to my angle if I want the opposite R? If I want to end up on the same angle so I can keep the same distance, what did I do to this angle to get those 2 answers? How do I go from pi over 6 to 13 pi over 6 to -11 pi over 6? What's the math? No, not just change rotation. Oh no. What did I do to this to get this answer? What did I do to this to get that answer? What did I add and subtract? Not 2, close, but you're off by a little bit. I didn't add 2 to it. I added 2 pi. If I add and subtract 2 pi, which is going to be 12 pi over 6. If I take pi over 6 and add 2 pi, I get 13 pi over 6. If I take pi over 6 and I subtract 2 pi, which is 12 pi over 6, I get negative 11 pi over 6. So what I did was, from here, I went all the way around in both directions. If I want to do the opposite r, if I want to end up here and rotate backwards instead of being here, what did I add and subtract? To end up on the other side, halfway around. Yeah, add and subtracted pi. So our rule is going to be, if you want to keep the same distance, a positive 2 distance, I'm going to add and subtract 2 pi. If I want to have the opposite distance, which means I need to be on the other side, I'm going to add and subtract pi. So without setting these up and even drawing the pictures, you can write the same distance twice, the opposite distance twice, and take that angle, add and subtract 2 pi for the same distance, and add and subtract pi for the opposite distance. All right, that's the idea behind the math. And we can draw it out, kind of figure it out, and figure out what those angles are, but just the math will give it also. All right, so do number 2. Find me 4 more polar representations of negative 4 comma 2 pi over 3. So if I want to keep the same distance, I'm going to add and subtract 2 pi. The 2 pi that I'm going to use is going to be 6 pi over 3. To have the opposite distance, I'm going to add pi, which is 3 pi over 3. And that is 4 more polar representations of the same graph. Because for my 8 pi over 3, I'm going to rotate all the way around and keep going, and then go backwards. For my negative 4 pi over 3, I'm going to rotate down into the second quadrant, and then go backwards. 5 pi over 3 tells me to rotate up and go out onto it. And negative pi over 3 tells me to rotate down. And since my distance is positive, I'm going to say stay on that line. That is the additional polar representations of the same point. If your distance stays the same, add and subtract 2 pi. If you want the opposite distance, add and subtract pi. Slow me down if you're not seeing something, so I can answer any questions that need to be answered. Same distance, add and subtract 2 pi. Opposite distance, add and subtract pi. All right, now we're going to do all our conversions. We have 4 formulas to convert back and forth between polar and rectangular equations, or points. We're going to change from polar to rectangular, rectangular to polar. We're going to have 4 equations we're going to use. X equals r cosine theta, y equals r sine theta, because think x is our cosine, y is our sine. So my x value is r cosine theta, my y value is r sine theta. Those are new. But the next 2, tangent of theta is y over x. We've done that forever this semester. And r squared equals x squared plus y squared. That's how we find our hypotenuse. That's the Pythagorean theorem. We've done that several times, maybe not written like that. We wrote it down one time like that, but we really don't use it that way. But r is your hypotenuse. That's your distance. So x equals r cosine theta, y equals r sine theta, tangent of theta is y over x, and r squared equals x squared plus y squared. All right, so I'm going to give you an ordered pair in polar coordinates r comma theta, 2 comma pi over 6, which we've done twice already. That's my r and theta. What I want you to find me is the corresponding x and y coordinate on my x and y grid that would plot me in exactly the same place. All right, so I'm giving you r's and thetas that we need to get rid of, and we're going to turn those into x's and y's. We have r's and thetas that need to turn into x and y. So if I want x's and y's and I have r's and thetas, I'm going to use those first 2. To find my x, I'm going to do r times the cosine of theta. To find my y, you're going to do r times the sine of theta. Do not use a calculator. Don't use a computer. Find me x and y. Substitute r and theta into both of these and evaluate for me. So figure out for cosine and sine of pi over 6. Decide where cosine is in which quadrant, which tells you if it's a plus, minus, 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 all that good stuff. Then take pi over 3 and write your reference angle. It's one of our reference angles, so find me the ordered pair that corresponds to pi over 3s and all the pi over 3s with the correct signs. And then find me the cosine value and tell me the sine value, and multiply them by 2. My thought is pi over 6 is in the first quadrant, so both pieces are positive. Pi over 6 is the ordered pair square root of 3 over 2 comma 1/2. Because 6 is 3 times 2 is how I remember. Cosine is my x value. Sine is my y value. So the cosine of x is square root of 3 over 2 times my r value, which is 2. And I get square root of 3. 2 times the sine of pi over 6 is 2 times 1/2, which is 1. So the ordered pair in polar, 2 comma pi over 6, is the same as the ordered pair, square root of 3 comma 1, in rectangular. Everything we learn comes back somewhere. Comes back to haunt you if you didn't learn it the first time. So all we're doing here, the only thing we really need to worry about is evaluating the cosine and the sine of our angle. I got a concern, a question. Something that's not making sense yet. I'm going too fast. I'm going too slow. All right, try number 6 then. Same idea. Find me the x and y coordinate that matches the ordered pair, 3 comma negative pi over 3. Negative pi over 3 is in the fourth quadrant. My signs in the fourth quadrant are a positive and a negative. My ordered pair for all my pi over 3s, 3 is 1 plus 2, so I'm going to do 1/2 comma square root of 3 over 2. And this is the ordered pair I get. 1/2 comma negative square root of 3 over 2. Then I'm going to multiply my cosine by 3 and my sine by 3. You get 3/2 comma negative 3 squares of 3 over 2. Concerns, questions, thoughts. All this is we have a new formula. And once we get that formula, for now, we should be able to substitute in and easily find the sine, cosine, and tangent of good angles. We've got to remember what we learned. Questions? Concerns? All right, let's keep going. Let's go the other way. Let's go the other direction. I'm going to give you an x and y. I'm going to give you a rectangular. I want r's and thetas. Okay, what I'm going to ask you for is two versions. You're going to find me two polar representations of this ordered pair. And you'll see why it's two in a minute. Right, so when we do these, I'm going to ask for two versions. I'm going to give you an x and a y, and you're going to give me two r's and two thetas matched accordingly. We just did 4 when we did our additional polar representations. This time I'm going to ask for 2. The point I'm going to give you is 0, -5. 0, -5. So we're going to mentally look at that and then figure out what we have. All right, to do it this direction, we're going to use the other two formulas. So what I want you to do first is I want you to find me my r values by using r squared equals x squared plus y squared. And then find me a theta value, or theta values, if the tangent of theta is y over x. So find me the r, and then we're going to find the theta. Remember, we're trying to find 2 of each. R squared equals x squared plus y squared, so r squared equals 0 squared plus a -5 squared. My math, which shouldn't be too much to think about. Because it's r squared, I'm going to get a plus and -5 for my r values. All right, my next thought. My tangent of theta is going to be my y over my x. So I'm doing tangent of theta is -5 over 0. Which means my tangent of theta is undefined. Because I'm not allowed, you guys know you're not allowed to divide by 0. You can't take a pizza and cut it into 0 pieces. It doesn't work. So, where is tangent of theta undefined? What two angles will I have where my tangent's undefined? Right. This also goes back to our graphing of our tangent functions. When we graphed a tangent, we found vertical asymptotes where my graph is undefined. Because that's where my graph does not exist. So that's where we drew our vertical asymptotes, and we curved our graph towards those. Okay? So think of it this way. On your unit circle, where's your x value 0? On your unit circle, where's your x value 0? Where? What? At the top? Yeah, because this ordered pair at the top is 0, 1, and 0, -1 at the bottom. So my tangent function is undefined at the top and the bottom. And all of my pi over 2's, whatever they are. So I'm going to say my tangent of theta is undefined at pi over 2. And then 3 pi over 2. That is where, when you put your y over your x, you're going to have some number, which is your up and down movement, divided by 0, which was your left and right movement. So tangent is undefined at the top and the bottom. So I have two angles. Pi over 2 and 3 pi over 2. And hopefully as we do these, it makes a little more sense. All right, so now our next part is we have to decide where they go. Does pi over 2 get the positive or the negative distance? Does 3 pi over 2 get your positive or negative distance? And how we're going to figure that out is I'm going to quickly mentally graph this point. which is going to be down at the bottom. So my ordered pair 0, -5 is down at the bottom of my graph, which is enough. So if I want the positive distance, I'm going to pick the angle that puts me where I want to be. Because I want to rotate to 3 pi over 2 and then go out 5 units. If I rotate to pi over 2, which is at the top, I need to go backwards to get to my point, so I want the negative distance. So we're going to find two distances by square rooting, getting plus or minus. We're going to evaluate tangent functions to find their two angles. The positive distance gets the correct angle. The negative distance gets the opposite one on the other side of your graph. So these are my two polar representations. We get 2 because of the plus or minus, and theta is always going to give me 2 answers. All right, so it's coming back. We have done these. We have solved these. We just got to remember it. All right, so we're going to use x squared, r squared equals x squared plus y squared. And we're going to use tangent of theta as y over x. All right, try number 8 for me. Take 8 as far as you can. And this one also should be done without a calculator because it's pretty answers. Well, so far today, we're going to use the calculator for one problem. That's the next one, but we're not going to use it at any other point. All right, so r squared equals x squared plus y squared. I'm going to square both out together and square root. Clean it up. Plus or minus 3 square roots of 2. It's 18. I'm going to do a factor tree. 9 and 2, 3, 3 and 2. My pair comes out to the front. For my angles, tangent of theta is going to be -3 over -3, which is the tangent of theta is 1. So to find my angles, my first thought, in what two quadrants is my tangent of theta, my y over x, going to be positive? My thought is my tangent of theta is going to be positive in the first and the third, because that's plus plus and minus minus. Now I need to see when I put my y over my x, I get an answer of 1. So what does that tell me about my y and x? They're the same. What reference angle has the same value for x and y? Pi over 4. So I'm going to pick my pi over 4 in the first, and my pi over 4 in the third. We get pi over 4 and 5 pi over 4. Right. When we do these aren't quick problems, we just spit out answers. I go through those steps every single time I have to do these. I just don't give answers. I say, truly, tangent of theta is 1. That means they're the same, which means they're a pi over 4. It's positive, so it's the first and the third, so I pick my 2 pi over 4s. All right, the angle I want, or the point I want, is down here in the third quadrant. So since it's in the third, my positive distance gets the angle in the third quadrant. My negative distance gets my angle in the first quadrant. And that's my math. Old material brought back to haunt you, especially those who don't remember it. All right. Do number 9. I will allow you to type 2 things into Desmos or into your calculator to do number 9. And it's both going to be in relation to the angles. All right, so take the ordered pair 5, 12. To find your R distance, your math is going to work pretty. To find your angle, I'll allow you to do the calculator twice. Or Desmos twice. Whatever you got in front of you to do it twice. Make sure when you give me angles, we're talking radian values. I don't want degree values. I want radian values. Take this as far as you can. Five squared plus 12 squared is 169. Square root of 169, hopefully we know is 13. My tangent of theta is going to be 12 over 5. I want 2 angles for theta. And the reason I said you can use a Desmos or a calculator or something is because 12 and 5 are not on my unit circle anywhere. When I simplify that 2.4, that doesn't help me either. That's why we're going to Desmos. When you get an angle, chat me an angle, see what we got going on, see what we got, who knows what. There we go, someone's got the first one. Now I want the second one also. And then change both of those to make them radians, not degrees. Radians. Remember, I want radians. Man, someone's on the ball today. All right, so if I give you a tangent of theta is 12 over 5, we don't know that, so we're going to do an inverse tangent. So theta is going to equal the inverse tangent of 12 over 5. And it's going to give me the angle 1.176. All right. backing up a step. What we said last time, if the tangent of theta is 12 over 5, I'm either in the first or the third quadrant because it's positive. Hopefully we remember that when you do an inverse tangent, the answers that it's going to give you are going to be between negative pi over 2 and pi over 2. It's going to give me that answer on the right side, where if it's negative, you're down at the bottom, it's positive if you're on the top. Inverse tangent gives me an answer between negative pi over 2 and pi over 2 from the fourth quadrant into the first. Doesn't go into second and third at all. That's where my answer is going to come out. Since this answer is positive, I know I'm up here somewhere. So my second angle is down here. To go from this one to this one, we've already talked about it a little bit, I'm going to add pi. So I'm going to take my 1.176 and hit plus pi and get 4.318. Don't add 1, add pi. Those are my two angles. Inverse tangent, when it spits out a positive answer, you're in the first quadrant. I need to get to the third. So I'm going to add pi to that answer and get my second. If it gives you a negative answer, you'd be in the second, or in the fourth, and then you'd add pi to get to the second. All right, so since the angle I want is in the first quadrant, I'm going to use 1.176. And then my negative distance, I need to be in the third. And I've used 4.318. We only go to the calculator when it doesn't work for the unit circle. Like this one here, number 9. Every other one, do it by hand. And you know those angles. And you don't have to think about that plus pi and the other stuff. You know what your angles are and what the corresponding angles are also. I'm getting good answers from 2 or 3 people at home. I'm hoping everybody else is following along or they're going to figure it out somehow. All right, this is our conversion for our ordered pairs, for our coordinates. What we're going to do now is we're going to convert equations. I'm going to give you a polar equation in terms of r's and thetas. And we're going to do anything and everything we can to change these into x's and y's. So I'm going to give you r's and thetas. We're going to change them to x's and y's. We'll talk about the shapes of these equations a little bit, but we'll get into more of it next class. All right, so we're going to convert equations. Polars and rectangulars. I have r's and thetas. Number 10, I only have r's. So what I need to do is I need to manipulate that equation, change the way it looks, so then I can do some substitution with these bottom equations to change it to our x's and y's. Okay. So I'm going to manipulate this equation, change the way it looks, so I can do some substitution with another equation to get rid of the r's and thetas. All right, so if I give you r equals 4, r equals 4, I need to get rid of that single r somehow to change it into x's and y's. All right, the way I look at it is I only have r's. This only has a theta in it down here, the tangent, so that's not going to help me. This has r's and theta, so that's not going to help me. So I need to get to be able to use r squared equals x squared plus y squared. My goal is going to be to end up with an r squared in my problem so I can replace it with x squared plus y squared. All right, so looking at r equals 4. What can I do to this equation so I end up with the r squared that I need? I need to end up with an r squared. So what can I do to this that's going to give me that r squared? Okay, what am I going to, someone said square it. What am I squaring? Because it is a little ambiguous. I'm going to square the 4. I'm going to square both sides. Yeah. I'm going to square both of these. So now I get r squared equals 16. All right, I want to change this first. So I'm going to square both sides of this equation and get r squared equals 16. And now I'm going to take x squared plus y squared and substitute it into r squared. And get x squared plus y squared equals 16. And we're done. So I'm manipulating my polar so I can substitute into it to get rid of the r's.
Oh, so we don't have...
You're done.
Oh.
That's it.
That's what I was going to do.
And we're done there. I got rid of the r by squaring both sides and substituting in x squared plus y squared. Now that my r's and thetas are gone, this is my answer. All right, so if I give you x squared plus y squared equals 16, then I ask you to tell me what it looks like. What's the shape? What's the shape of x squared plus y squared equals 16 if you had to graph it? Okay, and then a little over an hour ago, you turned in your test where you should have been able to tell me this. 2 positive squares with the same coefficient is a what? That was your test. So everybody should have, most of you should have missed it. It's a circle. 2 positive squares with the same coefficient. Now, what we wrote, if I told you to solve this, would be this. We would divide by 16 to set it equal to 1. That's normally what we did for our ellipses, where our left and right distance is 4, up and down distance is 4. All right, so that's the circle. For your homework that we gave last class, leave your circle looking like that. You don't have to divide. Okay, when you have a circle, when you have an x squared plus y squared equals a number, leave it like that. Knowing this now as I say this is going to help you with number 7 on your homework from last class. Okay. When you have a circle, don't divide by that number. Leave it over here. Have it as x squared plus y squared equals that number. Okay, that should help you on number 7, because if you divide it and try to plug this in for number 7 on your homework, it's going to tell you you're wrong. They want this. So that's a circle with a radius of 4. And if you look, a circle with a radius of 4, same idea. All right, so let's do number 11 then. Number 11, I'm going to tell you, just because we don't know yet, number 11 is a line. So when I'm done, I need to have the equation of a line written. Okay. So, going down here, looking at my equations. Since all I have is a theta, I'm going to use this one. I'm going to use my tangent. Since all I have is a theta, I'm going to use my tangent. All right, there's a couple ways of looking at this, but what I want to do is I need to end up with a tangent of theta in this equation so I can substitute. My original problem, theta equals pi over 3, I need to end up with a tangent in it. So I can take, when I have tangent of theta, I can substitute y over x in its place. So up here, if theta equals pi over 3, what can I do to this to manipulate it to change the way it looks? Not its value, just change the way it looks, so I end up with that tangent of theta that I want. This is probably something we haven't done much of, but it's the same idea as what we did in number 10. What can I do to both sides of this equation that's going to give me, again, that tangent of theta that I want? Okay, there's something that you're going to see that's very simple, just doesn't make sense. All right, let's look over here real quick. Look at the last one. I had an r squared, or I had an r, and I wanted to make it squared, so I squared both sides. I have a theta. I wanted to make it tangent of theta. What can I do to both sides of that equation? Tangent both sides. I'm going to take the tangent of both sides. There you go. So I'm going to have the tangent of theta equals the tangent of pi over 3. If I can square both sides, I can tangent both sides. As long as I do it to one, I can do it to the other also. All right, so I'm going to tangent both sides, and we said down here that the tangent of theta is y over x. Now, find me the tangent of pi over 3. Go through your process. Find me the tangent of pi over 3. And it should clean up pretty cleanly, pretty nicely. So I'm going to think pi over 3 is in the first quadrant. Everything's positive in the first. Pi over 3 is my reference point, 1/2 comma square root of 3 over 2. So when I take the tangent, I'm going to put my y over my x. I get square root of 3 over 2 divided by 1/2. Instead of dividing by a fraction, I'm going to multiply by the reciprocal. Keep, change, flip. And I get the tangent of pi over 3 to be square root of 3. Bringing back our evaluating trig functions. All right, now, getting to there. I said this equation should look like a line. I said it should be a line. So if I gave you this, and I said, tell me what the shape is, does anybody see a line? Anybody say, oh yeah, absolutely, that's a line 100%. No, because it doesn't look right. What can I do to this equation so it does look like a line? How can I manipulate it? How can I change it so it does look like a line? Our lines are normally y equals mx plus b. Yeah, just get rid of that x. Move the x over. You're going to get y equals the square root of 3 times x. So now that's a line that goes through the origin because my y-intercept is 0. That has a slope of square root of 3. And I'm good with that. All right, so we're going to take our original equations and we're going to manipulate them so my formulas underneath work for us. And once they work for us, we substitute it in and do what we need to do. Sometimes there's other ways to do these. As long as you can get there, I'm okay. I just want you to understand how you can change the equations, how we're allowed to tangent both sides if we want to. All right, what's the next one? Still, polar to rectangular. I have r and theta this time. I have r's and thetas this time. R equals 4 cosine theta. And all this, because when we change this around, like when we tangent both sides, once I said it, I hope it made sense, and we're allowed to do the same thing to both sides. Okay, but normally we don't do something like that. We square, we add, we subtract, we multiply. We normally don't tangent, but we can if we want to. All right, so look at number 12, R equals 4 cosine theta. First thought, what equation do you think we're going to use? We can use any of the four. Yeah. My first thought is, because I have a cosine theta, I'm going to use this. Okay, we're going to make that happen. So I need to end up with an R cosine theta in that equation. R equals 4 cosine theta. I need to end up with an R cosine theta somehow. What can I do? How can I make it work? How can I manipulate that so I end up with that in my equation somewhere? Well, help me out at home too. And don't think too hard. I need to end up with an R cosine theta somewhere in that equation. Like I said, don't think too hard. I probably need an R in front of that cosine, don't I? If I want this, I need an R here. So what can I do to get an R there? Don't think too hard. Okay, I can divide by 4. Okay, let's do that. Don't do this, just follow with me. All right, if I divide by 4, I get this. Then move the R over. Someone said do that, so I'm going to multiply by 1 over R. So now I get 1 over 4 equals cosine theta over R. That doesn't give me R cosine theta, that gave me cosine over R. That doesn't help me. Again, I'm not saying it's wrong, because what we did is mathematically correct, but that doesn't help, so I don't want to do that. Stop thinking so hard. How can I get an R right here? There you go, multiply both sides by R. If I want an R here, I'm going to multiply the left side by R, give me an R squared. And the right side becomes 4R cosine theta. Like I said, I mean, once we see that, you hopefully go, oh man, that was too simple. I needed an R, so I multiplied both sides by R, and I ended up with 2 good things now. I ended up with 2 good things because I got the R cosine theta that I wanted, and I also got R squared. So that's going to get rid of the R cosine theta and the R squared. So now I'm going to replace R squared with x squared plus y squared equals 4 times R cosine theta, which is x. And that's an acceptable answer, I hope. Sometimes WebAssign wants different answers than what I would say, but that's fine for me. And that is another circle. But that circle there is going to be shifted left or right or up or down because I have an x value. Okay. If they don't like this, maybe they want this in WebAssign. So if you type the first one and feel good about it, they don't accept that answer, move the 4x to the other side. And write it as x squared plus y squared minus 4x equals 0. That looks like a strange circle because it's equal to 0. But that's fine, because when you complete the square, you'd end up with a number. So if you need an r on both sides, or one side, multiply both sides by r. Just make sure what you do helps you in the entire problem and just not in your piece. Multiplying by that r helped us here, and it helped us there. And we got what we needed. All right, I think we have two more problems. Go the other direction real quick. Do number 13 for me. Get rid of your x's and y's and write it as r's and thetas. Get rid of your x's and y's. Write it as r's and thetas. 2 steps. I don't want to see an x or a y in your final answer. All I want to see is r's and thetas, and you don't have to have both. You just have to have at least one of them. So we change r squared to x squared plus y squared equals 9. I'm going to solve for r, because you always want r equals, not r squared equals r equals, and I get r equals plus or minus 3. Very straightforward, I hope. All right. Change this one. I want the best answer you can give me. We'll play a little game. I can solve this equation in 3 steps. See if you can also. Y equals 5. Get rid of that y. Write your answer in terms of r's and thetas. I don't know why my pen's starting to mess up now, but I have r sine theta equals 5. To solve for r, I'm going to divide by the sine of theta. I'm going to clean that up. I want one more step. So if r equals 5 over sine theta, what's the cleanest and best answer you can give me? What does r equal? Anybody? Alright, so I'm going to change 5 over sine theta to 5 times 1 over sine theta. I'm going to take that fraction apart, which hopefully once we see it, we're not going to need to do. So if I have 5 divided by sine theta, which is 5 times 1 over sine theta, what is 1 over sine theta? What is it? 1 divided by sine is the same as reciprocal identity. Great, everybody said it. 5 cosecant theta. Dividing by sine. This reciprocal identity is the same as multiplying by cosecant. That's your cleanest, best looking answer you can give. So what you have to do when you're getting rid of x's and y's and writing r's and thetas for equations is do your substitution, solve for r, and clean it up the best way you can. All right, so that's today's lesson. Next class, we're going to come in and we're going to graph these equations. I'm going to give you r equals 5 cosecant theta, and we're going to graph the equation and see what it looks like. All right, so we need that graph paper. We're going to do it on Desmos, so we don't have to do a lot of the math. We just have to know the setup. Tuesday, section 6 and 7, parametric and polar. The first day of polar is due on Tuesday. So make sure you get that done. If for whatever reason you haven't turned your test in, you need to submit it now. Just do it over an hour or hour and a half ago, and it should be done. If you have any questions, let me know. I will be available for tutoring tomorrow from 12:20 to 1:20 if you need to ask. If not, I'll let you go. Have a great weekend.